A machine builder's repository of knowledge is changing. Actually, it already has. As control design has covered this subject over the years, we've seen how the industry nurtures and trains controls engineers and builds machine automation professionals from scratch. We've also explained what machine builders were doing in sometimes brutal financial conditions to keep as many engineers on staff and motivated as possible, and some that took the opportunity to enhance training or retool systems during the slow period. But now that flat has become the new up, more machine builders are realizing the benefits of retaining the automation knowledge that they've spent years and money to develop in their engineers. They're doing this by using standards and modular design that rely less on individual automation superstars and more on collective knowledge and teamwork. We'll talk with some machine control professionals about this subject after this short break. So what are machine builders doing to retain the automation and technology knowledge they've invested in so heavily over the years? And how are they leveraging that accumulated engineering experience and insight? The cover story in the February 2010 issue of Control Design looks at some real-world answers to those questions. For example, using standard designs and existing components and merging them allows CBW Automation, manufacturer of high-speed retrieval systems for injection molding applications in Fort Collins, Colorado, to use junior designers instead of senior engineers to complete a unit. By assigning tasks involving reuse of existing work to newer engineers, senior project engineers who already have that standardized experience are free to design more advanced custom solutions, says CBW's Steve Corwine. Craig Souser says although his company, JLS Automation, is a system integrator, it functions more like an OEM. JLS, which is located in York, Pennsylvania, looks for common elements required in each system and then deploys its design resources to develop a set of modular building blocks that can be configured. We also spoke with two other companies that are well into knowledge retention and putting their expertise to good use time and time again. First, Concept Machine of Northbrook, Illinois, has 40-plus years of design and build experience. Control Design Executive Editor Jim Montague spoke with Concept's Chris Lovendahl about how the machine builder retains and leverages automation know-how by thinking through the processes.
Chris, thanks for talking to us today.
Glad to have you here.
All right, great. The first thing we'd like to talk about is, what is the need for machine builders to use standard components and methods in the first place?
Well, all of our machine solutions are custom. So we're looking for a means to make it easier to build a machine, lower the risk of a new concept or a new technology. So we have been trying to build these standards for about 30 years. It's really been the last 5 to 10 years that the technology has really caught up to where we need them to be.
Mm-hmm. So what are some of the technologies and tools that you use to accomplish that standardization?
There's been a lot of improvements in CAD technology, computer-aided design. We went from basically replicating drawing on a piece of paper in a 2D world to full 3D SolidWorks now. Mm-hmm. Mm-hmm. SolidWorks being one of the softwares used. So you can see the interference of parts being bolted together, interfering with each other, how the tooling works with the customer's product. Mm-hmm. It's also more realistic for them to view before we actually build the machine to see how it's going to work.
All right, then. How do you reuse existing automation system designs as opposed to designing from scratch?
We tend to group the technologies together. For example, if you're doing an assembly process where you're pressing two components together, mm-hmm. we design that from the outset to be ready to do a whole variety of parts in the future. All types of processes we use in assembly machines, a lot of them can be reused. So we got a baseline with that first design, and we keep it. Mm-hmm. Once again, like the electronics of today help us to do that.
Okay. How can a machine builder system maximize reuse with minor modifications instead of doing a major redesign?
I think you've got to look in the long term. You're designing a machine or a station or a technology for the first time. We're often thinking, what can we use this for in the future? So we might make a design a little bit larger, a little more open, or a little bit more accommodating to different tooling in the future.
Okay, what skill sets are needed to help reuse of existing practices, and how do they differ from completely new designs?
It's a combination of people. They've got to know how to use their design tools, but you also have to have people that are used to, as in our business, designing machinery, to be able to understand what's going to happen in 2 or 3 years, or what's happened 5 years ago. So there is a level of experience you've got to have to think ahead of time about what I'm designing now and how we can reuse it later.
Okay. As standards-based machinery becomes more widespread, is it also becoming more homogeneous internationally?
Yeah, I think it has. The products we use to integrate our machinery, typically we build a machine in the United States here. Our customers in Asia and our customers in Europe will typically be able to find local sources for all the components in that machinery.
All right. Chris, thanks for a great interview today, and thanks for your insights.
Thank you.
All right, Mike, back to you.
Now, of course, reusability is what drives the forethought put into machine design at companies geared to keep and repurpose their engineering efforts. Bradbury in Mound Ridge, Kansas, builds machines for metal forming and coil processing using an approach called total system control, which utilizes a control solution framework, and the standards are based on collective years of internal controls experience, along with industry standards and best practices. Plus, designing a system for reuse requires a greater initial investment of time, so all known variations can be considered. Our team members work together to develop a solution that we all can maintain and support, says Larry Asher, Controls Engineering Manager at Bradbury. It's a process designed to make us more efficient by reusing existing solutions, he says. DMC, a system integrator in Chicago, created a solution for a Tier 1 automotive supplier that required the ability to customize what it produces based on a common core. The solution stores all of the sequencing logic in a recipe system, so the end user can modify any of the sequences by using an intuitive configuration screen in the software. We use an object-oriented approach to software design, including modularity, encapsulation of code, and well-organized data structures, says DMC's project director, Tim Yeager. We take the time to design each system so that it can be reused easily, he says. Howmiller Engineering builds high-speed automated assembly machines in Elgin, Illinois, and has more than 4 decades of experience behind the documented methods, standards, and tools it employs. At Howmiller, the ultimate goal is building a reliable, accurate machine. Control Design Chief Editor Joe Feely talked with Howmiller's Pat Phillips about reusing modular design components and standardized methods at a company that focuses on custom-built solutions.
So Pat, your company has some ideas about how to minimize the risk of having to find and hire automation superstars. And you've talked a little bit about how that's involved with using standards, using modular design so you can build the machines you want and still have them be easier to operate, easier to maintain. Tell us a little bit about how that works.
Well, if you look at a machine like this where it obviously has a very complex control system, the important thing is to recognize where we have done similar things before. And essential to that is a very good documentation system that enables easy retrieval for the engineers. That way they can say, although we've never done this entire package for anybody else, we've done certain modules that are very similar, so we don't have to repeat the concepts and all the complexities that go with that. That greatly reduces our debug time and also increases our ability to train somebody who may be new within the company.
Okay. So Pat, tell us a little more about reusing the modules of design. You probably can't use those modules in every project, so typically how much can you reuse from project to project?
That kind of depends on if the customer's the same customer and if it's the same package being run. But probably the most important thing for us, both controls engineering-wise and mechanical design, as whether or not that same concept has been used before. Because the concept is really where all the risk lies. Executing the mechanical design or the controls design is a much lower risk than the actual concept of how everything's going to work. In this particular case here, we have a can cap orienting machine that's running at 450 cycles a minute. We've never gone that fast before, and we've never had all these bells and whistles together on one machine. However, we have used this method of orientation before, so we took that risk out, and we don't have to redesign that mechanism, only prove that it can achieve the speeds needed, and then customize it for this existing customer.
Got it. So in terms of the skill sets that your engineers need, is there a difference in the skill sets of an engineer who's relying on reusing design modules from time to time versus an engineer who's building new modules from scratch?
The technical skills really aren't any different, but actually the engineer that is also customizing and reusing modules needs to have a broader understanding of how the cost of the product impacts our business and impacts the customer's business. They actually have to understand how we work within our own company and have to understand how that system works where we retrieve those modules, keeping the cost down in certain areas.
Got it. Pat, thanks very much for this.
Thank you.
Mike, we'll throw it back to you in the studio.
Standards programs and modular design require a team-oriented engineering mentality. The face of automation know-how retention has been changing for some time, but the economic impact of the past couple of years has brought more attention to its evolution and its benefits. We hope we've provided some valuable takeaways to you with this insightful look at our 2010 cover story on retaining automation know-how. And be sure to read the entire piece on our website. For Control Design, I'm Mike Bassador. Thanks for watching.